If you walk into a casino and bet $100 on red, is there a way to mathematically prove whether that game is a sound financial investment? To find out, we have to define exactly what we are measuring. The random variable, which we denote as X, must represent the actual financial profit or loss of the bet, rather than the physical color of the pocket. For a $100 bet, a win gives us a profit of positive 100. A loss means we are out negative 100. Translating physical outcomes into positive and negative numerical values is the required first step. We cannot apply mathematical risk formulas until we have concrete numbers to evaluate. This chart shows the layout of a classic European roulette wheel. There are 18 red pockets, 18 black pockets, and 1 green pocket. That gives us a total of 37 possible outcomes. We use those totals to build a probability distribution table, starting by mapping the winning scenario. The probability of an outcome of positive 100 is 18 out of 37. Next, we map the losing scenario. It is easy to fall into the trap of thinking a bet on red is a 50-50 coin toss, but a loss happens if the ball lands on black or green. That makes the probability of a negative 100 outcome 19 out of 37. Now we apply the standard expected value formula. We take the sum of all outcomes by multiplying each outcome by its probability and adding them together. The result is negative $2.70. This number tells us that over the long run, a player loses an average of $2.70 every single time they spin the wheel. The math proves the existence of the house edge. Working with negative numbers inside distribution tables can be clunky. Instead, we can use a gambling-specific shortcut formula. Expected value equals the amount won times the probability of winning minus the amount lost times the probability of losing. Be careful here. The amount lost plugged into this new formula must be a positive 100. The subtraction sign in the formula already accounts for the mathematical loss, so making the 100 negative will break your calculation. Let's test this on an American roulette wheel. This layout has 18 red pockets and 18 black pockets, but adds a second green pocket, the double zero. That makes 38 pockets total. Pause the video here. Use the new shortcut formula and these variables to calculate the expected value for a $100 bet on the American wheel. A tiny physical change in the game's environment, adding just one single pocket, forces a recalculation of the entire mathematical risk profile. Welcome back. Following the shortcut, we take 100 times 18 over 38 and subtract 100 times 20 over 38. The final result is negative $5.26. Let's look at that alongside the expected value of the European wheel calculated earlier. Adding just one extra green pocket nearly doubles the player's expected rate of loss. This explains exactly why casinos prefer the American wheel. To solve these distributions, remember 3 steps. First, define the random variable as your financial payout. Second, account for hidden losses, like the green slots, in your denominator. Third, apply the betting shortcut carefully using positive values. Mastering discrete probability distributions strips away gambler superstition. It allows us to view risk purely through the lens of concrete, verifiable math.